All right. Good morning, everyone. Can you hear me online?
Yeah, we can.
Okay, thanks. Okay, so today is a little bit of a different setup, at least for those of us in Athens. And I hope you are all safe and that you also enjoyed the snow that we got. Um, as a reminder, I do ask that you turn on your cameras for these Zoom classes, especially. So please go ahead and turn your camera on. We're going to get started here. And before I really dive into today's content, I do want to ask how was it with the Git in GitHub exercise? I'm assuming everyone was able to complete it, but was someone not able to complete it for some reason? If you'd like to share your thoughts on that.
Professor, I had a very, I don't know, strange experience with that. So I was able to do it with RStudio, but when I was doing it through terminal, the directory was not working. It was saying could not find that directory. But when I followed the whole procedure through RStudio, it worked fine.
Okay. So when you were trying to go through the terminal, Umar, you were having some issues, but then as you did through the RStudio IDE, following the instructions, then it worked out. Is that right?
Yes. Yes.
Awesome. Was someone else having issues, or maybe was someone else not able to complete the exercise? All right, so I'm assuming everyone was able to get through all that and get your Git and GitHub connected. We're gonna start using Git and GitHub every new exercise, and so it's important that you were able to get all that going and connected. If you are not, we can always help you troubleshoot things. I can, use the resources that we already established as far as seeking help on GitHub, and then Arinder, and then myself. But I guess I'm assuming that everyone was able to do that successfully. Okay, so today we have a couple of lectures mostly, but nonetheless, we'll be requiring activity from your side, even though we're not going to be coding, but we're going to be doing some things that will require you to also do on your side. So the first one of them is if you come to the homepage of the course. So on my website, we do have a set of slides that I want to go through. They are still the ones under January 21st. So that is the set of slides I want to ask you to open. I mean, if you don't want to open, you don't have to. You can see that in my screen, but I do want to go with you through this lecture first. So I can show you, and we can set things up so you understand exactly how we're going to be using GitHub in this class and for what purposes. All right, as a reminder, if you want to download the slide deck, you can just push E on your keyboard, have a continuous scroll view, and then go on your browser on File, Export as PDF, or maybe print or export depending on your browser. Did someone have a question before we started? All right. I don't hear anything, so I'm gonna get started. All right. So today, for this first half, I want to show you what we're going to be doing and how we're going to be using GitHub in this class. So I want to show you the workflow specifically for this class and what we're going to do. So today's goals is through this exercise, we're going to check again if Git and GitHub are talking on your side. I want to define our GitHub workflow for the remainder of the semester. So again, I'm going to show you what we're going to be doing in every new exercise, how we're going to create the file structure on your side, connect Git and GitHub, and then also how do you retrieve data from GitHub when I share that with you. we're going to fork and clone the class repository. And yeah, that's basically what we're going to be doing for this first hour here is, I guess, learning how we're going to be setting up the files on your side every new exercise, and then forking and cloning the class repo so you get the new files whenever I share those with you, and you don't have to manually download it. You can just do a git pull in that case. All right, so today we're going to go very slowly, step by step, in simulating a new exercise that we're going to work on. So not today, but probably next Tuesday, we're going to do a new exercise called 04RCBD for randomized complete block design. So that's going to be our first coding exercise with experimental design data. And so from this point on, every time I send you an email saying, hey, before class, create a GitHub workflow for an exercise called X, where in this case, X is 04RCBD. I'm going to lay down next the steps of what I want you to do when I email you saying that, right? So all of these steps are outlined here on chapter 12 of that ebook that you used on the previous class. So connect RStudio to Git and GitHub in case you need a more in-depth reminder. But if you just follow the steps I'm going to outline here, that should be sufficient. So the first thing, and this is going to be really interesting and a different mindset even. The first thing we're going to do is create a repo on GitHub. So we're not going to create a folder first in our computer. We're going to do that first on GitHub because that makes it easier to connect GitHub in your local computer. If you start on your computer, you may require a few more steps that add complexity to the process. So we're going to follow the workflow of starting on GitHub first. So let me actually just keep this window on the side, and I want to invite you to do this along with me as well. I'm going to have a couple of browser windows here. So one of them we can follow the directions. The other one I can do this along with you. So the first step again is going to be making a repo for that exercise on your GitHub account. So I'm just going to roll this and we can see all of the directions. So if you go on your GitHub, as I'm going to go on mine, so again, this should be on your personal GitHub, right? So you can click on your picture there and go to your repositories. If you already have previous repos, you're going to show them here. If you don't have, this may not show anything, but the key thing is just for us to click on that new repository. So we're going to be creating a new repository on GitHub. So click on that. You're going to get a few options here of things that we need to set up. So the first one is going to be the name of this repo. On your side, I do want you to call this 04_RCBD. Again, we're using the 04, so our exercises are all sorted alphabetically and in a way that makes sense. RCBD is just a short name for what that exercise will be. In my case, specifically, I already have a repo with this name because, well, when I taught this class last semester. So in my case, I'm going to add a _25 just to mean that it was 2025. You don't have to because you're probably not going to be creating 04RCBD more than once. So you can just call it 04RCBD and stop there. You can add a description. Oh, okay. Swabir has a question. Go ahead, Swabir.
Can you hear me? Can you hear me, please?
I can hear, yes.
Yeah. I get confused. Like, I saw you go to your profile, but I didn't know how you got here.
So if you just go on, so let me repeat that then. So I'm going to open a new tab here, close the old one. I really just went on my browser and went on github.com. It kind of depends. So this is the view that I'm getting. I think it will most likely have a similar view. If you're seeing what I'm seeing right now, you could create, you could just click on that new button to create a new repository. What I did is I clicked on my profile picture on the right, and I clicked your repositories.
That's what I was missing.
Yeah, and then I clicked on that new.
Thank you.
Yeah, thanks. Yeah, if anyone has any questions or issues, you get stuck, you get behind, let me know. I'll be glad to repeat any step. All right, so if you clicked on that new, we need to give it a name. Again, you can name it 04_RCBD. I'm gonna add an _25 on my side because I already have a 04RCBD from last semester. You could add a description if you wanted. I mean, for right now, we're gonna leave it blank. So here's where you would choose if you want this to be a public or a private repository. So public, anyone that goes on your profile can see that repository, can access it, can clone the repository, or fork and clone in that case. If you make it private, it's not going to be listed. People are not going to be able to see it. And for anyone else to be able to work with that data, you have to invite them through the settings of that repo. So for now, we're not working with anything proprietary or anything that should be hidden away at this point. So we can just keep it public. That's what I would recommend for all the repositories of the class. I want you to check this box for add a README. So a README file is a very common file that every GitHub repo probably has, which is whenever you land on a GitHub repo, if it has some text below it. So, if I just open a new tab here to go to our class repo, just to show you. So it has a README as its files, and the README is what GitHub displays on the bottom. So this is what is inside my README for the repo of the class. So as you can see, we have some links, we have a photo. So it's really just markdown language that GitHub treats with a special care. If you have a README in any of your folders, especially on the first one, GitHub is going to render that for you and show you as a render file like it is here on our class repo. Right. Let me close that. Just wanted to show you what the README is and come back here. All right, so we made it public. We added a README. Let's add a git ignore. So a git ignore is basically a file that Git on your local machines keeps track of, and basically ignores those files or maybe those file types or maybe a folder specifically within your project. So let's say, for example, keeping track using Git of Word files is kind of messy. It's not really easy for Git to do a good job keeping track of Word files. And so normally I would just add any Word file to my git ignore. So Git does not even try to keep track of it. And I do that through this git ignore file. You're going to see what that looks like when we're done with this. But for now, I want you to, so right now it's saying none. I want us to click on that drop down menu. And then as you can see, there's a lot of templates of git ignore for a lot of different languages. We're using R, so I want to go all the way down to R. So I want you to click on R. For example, if you're actually developing software, which you may end up doing that at some point, if you want to write an R package, maybe a Python library, and you actually want to be able to get to use a license, a distribution license for whatever code you're using, you can choose a license right here. We're just going to leave it blank. That's not exactly what we're doing here, but that's an option you have there. And then click Create Repository. So this basically should have created now under your profile a 04_RCBD. If you stop the name there, I have the _25. So it is a repository that at this point only exists on GitHub, right? And this is the name that I gave it. You can see that it created two files for us in this repository, the git ignore and the README, and that's it. All right, so this is us starting on GitHub first, right? So every time we have a new exercise, we're going to start that on GitHub and then clone that repo into our computer and then make all the changes that we've been doing already as previously done. Okay, so if I come back to my presentation, we've finished that step of making a repo on GitHub. Now we're going to clone this repo to your local machine. I'm going to roll all the steps here, but basically we're going to click here on the code button. When you went through the guidelines on the previous exercise to set up Git in GitHub, there was a step where you set up your HTTPS token. I am assuming you did that through HTTPS. You had the option of doing through SSH if you wanted, even though it was not recommended. So I'm gonna assume you did through the recommended route, which was HTTPS. You can go ahead and copy this URL here to your clipboard. Now, the next step is gonna be to create a new RStudio project. So I'm gonna roll all the steps here. But basically, so now we created the repo on GitHub. We copied the address of that repo, the Git address, which is not just, so if you notice this address here, it's not the same as you copying the browser address. So always make sure you go through here, HTTPS, and copy this address through here. So now we're gonna go and launch an RStudio window. It could be any, even if you already have an RStudio window open, you can just go ahead and pull that up. So I have here my RStudio project that I have for the website. I'm just gonna close this project and have a project none. You can do the same if you wish. If you don't want to close your current project, you don't have to. This is just for me trying to make it a little bit simpler on your side. All right, so let me make this smaller so I can see the instructions as well. Down here. Oh, didn't work as I was thinking, but all right. Okay, so now we're going to basically create an RStudio project, but through Git and using Git with it. So as we did the first time around on the 0 Wrangling project, you come up on the top. If you have project none, that's okay. If you already have a project open, that's okay as well. I'll just click there. We're going to go to new project. Here we have the three options. What we used the first time around was existing directory. From today onwards, for the remaining of the semester, we're going to be clicking on version control. So click on version control, and we're going to click on Git. So this, I just want to take a quick step here and ask if anyone is not seeing this Git option on your RStudio. It could be, you may not be seeing this if you have an older version of RStudio. I hope that you're all seeing this. All right, so click on that Git option. Here we have a few fields that we need to fill in. So the first one is the repository URL. This is what we just copied from GitHub, right? So if I just come here and paste, I'm just pasting that. And again, just as a reminder, notice how this address here has a .git in the end, and this is that HTTPS address that we copied, right? If you just copy your browser address, it's not what we need here. We need the actual link that we get when we click on code and then copy. So just to show that again here, if you come on code and then copy this address, this is what we need here, right? I'm not using my browser address. That would not be the correct one to use. All right, on project directory name, if on my side it is blank, I'm just gonna leave it blank. If on your side it's not blank, you can just leave whatever it is, but we don't have to change that otherwise. And then lastly, we're gonna define where in our computer I wanna create this. So I want you to click here on the browse button. basically I want you to navigate to this level. So I want you to be looking at the main folder of the class on your computer. I don't want you to be like selecting another subfolder or maybe going inside another subfolder like 01 intro. I don't want you to do that. I want you to be at this level here where you see the 01 intro, 02 wrangling, and I think on your side, that's probably going to be it. And maybe you already have the 2025 DSA main that until this point you were downloading manually, which you're not going to be doing after today. So if navigate to this folder on your computer, wherever that lives, and once you're here, make sure you don't have any of the subfolders selected. Once you're here, just click open. All right, and then after we've done that, you can go ahead and click on Create Project. So this is basically gonna switch your RStudio environment to a brand new RStudio environment or RStudio project focused on that folder. All right, so a few things I want you to notice here. The first one, so it did launch, it is showing to me 04 CBD 25. Yours may just be 04 CBD. If you come on the Files tab and we click on the R blue button to take us to the home directory of this project now in your computer, not only on GitHub, but also in your computer. These are the files that I see, right? So if I open this git ignore, this is basically just ignoring. So what is it ignoring at this point? So this is, if you remember, we chose a template of git ignore for R. So it is already somewhat customized to ignore some files related to R. So it is ignoring or is not keeping track of our history files, our app history, our data TMP files. There's a few other file types that is not keeping track of, and we can see that here. If we wanted to add something here, we could add, if you want to ignore Word files, for example, this is where we would add that. But just wanted to show you what that git ignore looks like. I'm going to go ahead and close it without making any changes. And I do want to show you here, if we click on the engine button and ask to show folder in your window, this is going to show in your computer where these files live. Right, so I'm seeing here the main folder of this file. If I navigate one level down on this folder structure, you should be at the main folder of your course, where now you have the 04 RCBD on your side. Right, so basically, again, we started on GitHub, we created the 04 RCBD 25 on GitHub, and then we came to your local computer, created an RStudio project using Git and version control, gave that URL address or the Git address for your repo on GitHub, and then RStudio basically brought those files, connected your local Git with GitHub, and already gave you an RStudio project by default with that. So to make sure,
Dr. Bastos, I have a question. Can I give?
Sure, go ahead.
What could be the reason I just see script parts? I don't see any of this environment part or console part, but I open there are 4 underscore RCBD
So you mean
project.
on your computer, you can see the 04 RCBD?
No, I just see on RStudio only the script part. I don't have the file part, environment part.
So you're saying that your RStudio, you're not seeing this whole right side?
Yes, exactly.
Interesting. Anyone else having a similar issue?
I think I can tell you the solution. You should go to view, like you need to click the view button and
Mhm.
then click show environment
Okay.
and then show files.
Yeah,
It
I
should-
got it. Thank you, Shakir. Thank you.
Check here.
Thank you.
Yeah, that was interesting, Aitan. I'm not sure like what
I'm
caused
so sorry.
No, you don't have to apologize. I mean, I was just trying to think of what could have caused it, but yeah, Shakir gave you the solution. I was trying to understand like what could cause it, especially if other people went through it. But I'm glad that you were able to figure out with Shakir's help.
Thank
All
you.
right. So let me see here. I think I was showing you this window. So for you to make sure that it worked on your side, at least to do the clone, right? You should now see the 04RCBD folder on the same folder that you have your all the files for the course. So at the main level of the course folder in your computer. If you cannot see that, then maybe it didn't work. We have to troubleshoot that at some point before next Tuesday. Assuming everyone was able to do it, then we're gonna keep moving here. So whenever I tell you, create a GitHub exercise 04RCBD, what I mean by that is you creating on GitHub first, cloning through these steps, and then you would come inside of this folder. And as you probably already are thinking, you would create your subfolders data, code, and output. Right. So on your side, you need to create those subfolders. And then after this stage, the next stage is I will be sharing some files with you through the 2025 DSA repo. And in that case, then you have to go retrieve those files, which at this point, you've been doing that manually. You've been downloading that as a zip. I want to show you how to do that in a more automated way without having to download with a zip, but just using GitHub for that. All right, I'm gonna bring this out of your view for now. We'll come back here.
Dr. Bassett, I have a question.
Yes.
So when we're making the subfolders, is it easier or more correct to do it on GitHub, or should we just do that as we've been doing it locally?
So we will do that locally.
Okay.
Something you're gonna notice with GitHub is even when you do them locally, after we stage, commit, and push, the folders really only show up on GitHub if there are files in them. So if you already created, let's say, the output folder, but you have not exported any graphs yet, even if you stage, commit, and push, the output folder is not going to show up on GitHub. So because of that, on our side, we still want to have that structure, and that's why we're creating locally. But when we do push, it will go through to GitHub and show up on GitHub only if there are files there. Yeah.
Okay, thank you.
Thanks, Jonathan. All right, so we finished our step 3 here. So just a recap, right? So step 1 was creating the repository on GitHub first. Step 2 was to copy that Git URL for that repo. Step 3 was creating the RStudio project here and bringing that GitHub directory and repo to your local machine. So now you can actually play with that on your side. And then once you created this structure on your side, right? So at some point, you're going to have a script in the code folder, for example. And then we're going to be working with that script, developing that script. You will be staging, committing, and then pushing to GitHub, right? So we're going to go through a little exercise about that. So the next step here is from changes to commits. I want to ask you to do this with me on this next step here. So what I want to do is show you how would it be the workflow of you making changes to a script and then staging, committing, and pushing to GitHub in a way that all the changes you make locally are reflected locally, but also on GitHub. So quickly showing you here as it should be on your side as well. If you go on GitHub, your 04RCBD, that's it, right? It has a git ignore, it has a README that it really does not have a lot of information at this point, and that's it, right? Now on your computer, which you just locally connected, you're cloned this GitHub repo to your computer, so they're connected now. So on your computer, we're going to do a few things. If you come back to that RStudio project that was created for the 04 RCBD, and if you're seeing your Files tab here, you can click on the R blue button just to make sure you go on the main folder of that project. I want you to click on that readme.md file, and it should open up on the side. So again, a README is just, so the MD extension stands for Markdown. Markdown is a syntax language that's very simple, that is used a lot for, especially if you're writing scientific notation. Markdown has a lot of features for us to describe different formulas and really complex things in math and chemistry and physics that I normally don't use a lot, but it is a language that's used for that. In our case, we're just going to use Markdown with some of its simplest features. So to begin with, as we opened that README, all they had there was a one hashtag and then the name of the repo. Maybe let's just rename this title of this README to be something a little bit more professional, right? So maybe we could just say like exercise for RCBD, something more human friendly and readable, right? Then if you hit return a few times, I just want to add a description here. So normally READMEs would add a description of what that repository contains and what it has, right? Perhaps you can even say when it was developed or who was the person that developed the script, whatever it is, right? We're just gonna, I just want you to write something simple here, perhaps, I'm just gonna write something like this REPL was developed by, or it was developed to do an RCBD analysis, something very simple. So this REPL was developed to conduct an RCBD analysis, period. So I'm not going to be showing you a lot of ways to style a Markdown, and there are many tutorials, there are many cheat sheets out there. If you just say like how to style a Markdown, you're going to find it. But just something that I just want very simple here. For example, if we wanted to make the word RCBD bold, we could just add two asterisks before and after the word we want to make bold. This, whenever it renders it, we're going to see that bold. Also, I think this is a good time for us just to look at another feature of not just Markdown files, but RMarkdown and Quarto. If you see here, we're looking at this on the source view. If you click on the visual view, this basically renders for you your code. You can still code here. You can still write things here as I can still write here normally, or even add code, although not on Markdown. So on Markdowns, we're not going to add code. So on your Markdown, I just wanted to show you that you have the visual and the source view, and you can toggle on or can toggle back and forth to see the difference. This is also something that we can do with our Markdowns and Quarto. I personally prefer the source view when I'm coding, but if you do want to see how the render version will look like, you can use the visual view for that. Okay, I'm just going to delete this because that was just extra stuff that I added. Okay, so once you made your edits, so you edited the title, you included some text here. I want you to go ahead and save this README by just clicking on that save button. And now we're going to, so think of it. The README was created on GitHub. We cloned that. It was very, very empty at that point. We made some changes. We edited the text, the title. Now I want to stage, commit, and push so I can see what the changes I've made locally represented on GitHub. Excuse me, on GitHub. So I want to show you how to use Git using point and click within RStudio. If you've already been using Git and you want to use the terminal or the command line for that, you're welcome to do that as well. But I want to show you the slightly more friendly way of doing that. So on my side, I'm seeing here the Git pane on my right next to the environment. If you are not seeing that, you can go to view and then show Git. So that would pop up there. You have that option. So if you remember, for us to keep track of files using Git, we first need to stage the file for which we want Git to take a snapshot of. And then after staging, we do a commit. And then for that to be represented on GitHub, we need to push, right? So those three things are what we're going to be doing here next. So with the Git pane open, this is how it should look like for you. Notice here that there is a column called staged, and both the rproj and the README have not been staged. I do want to stage the README. So if you just click on that README, it brings it to the staging area, if we can think of it. And then the README now has been staged. So now we're just telling Git, I want you to take a snapshot of this file, but it has not taken that snapshot yet. I'm just indicating which files I wanted to take that snapshot. Now on top here, there's a few button options on the top. I do want you to click on this check mark, which is to commit. So if you click here, it's gonna show you this window. It is showing us the README file. It is showing us what we changed. So it's basically showing that we deleted this line here. And then we deleted what's in red, we added what's in green. That's exactly what happened to this file. I want you to come here on the commit message and let's just write something, right? Every time you do a commit, especially as you're working with more complex things, we want our commit messages to be short but informative, right? So here, what I want to do is just say like updated README. Very simple, short, but I know what it is. In this case, it's really not that important, right? It's just something very simple, but sometimes you may have developed 500 lines of code that you want to commit. It's useful to say, created the ANOVA, the analysis of variance for yield or something, whatever it is, right? You do want it to be short, but informative. Now go ahead and click on commit. So this probably showed you the git commit log here, which is basically just giving some information saying that one file change, 3 insertions, 1 deletion, depending on how much you wrote on your README. You can go ahead and close this window for now. And I want to show you a couple of different ways for us to now push. So again, stage and commit happen on your computer, on your machine. You have not pushed it yet, right? It's not on GitHub yet. Now, how do we make it to be uploaded, those changes to be reflected on GitHub is by pushing it. If you're still within that window that we opened when we clicked on this check mark, you can click this push button if you're there. So just go ahead and click push. Again, it gives you some text here just to saying that it was pushed to GitHub. You can close this window, and now we don't see any more changes reflected here that need to be tracked. You can close this window here that I'm showing you. So we go back to our studio. You could have also pushed by just clicking on this shortcut here. So you don't have to open the commit window to push or pull. You can just use that button there to push. All right, now how do we know it actually worked? So if you go on the GitHub side, so on your browser, and you go back to that same repo that we're working with, and you just refresh the page, now you should see the changes reflected on the README. And again, we only changed the README, so that's the only thing that I would expect to be different, right? But we should see that reflected there. Also now, if you come on your commit history, you can click there. This was the change that I just made, updated README. This is the message I gave, right? It shows up here, and you can navigate the files. You can see what files were changed, where, how, by who, and so on. All right, was everyone able to do this? Were you able to change your README, stage, commit, and push? And then once you check on GitHub, you saw your changes reflected on GitHub. Was everyone able to, was someone not able to do this? Okay, I don't hear anyone saying that we're not able to do so. I'm assuming we're all able to do this. So this is a great sign, because if you were able to push, then it means your local Git is connected to your GitHub. That is perhaps one of the trickiest parts, not trickiest, but more demanding to get it through, as you all did on last class. So if that happens successfully, then you're good. Just to tell you again, you will not have to do everything you did last class again. The only thing you're going to have to do is what we're talking about today, which is creating a new project or new repository on GitHub, cloning that to your machine, creating the subfolders, and so on. Right. So this is basically the workflow that you're going to be repeating many times this semester. Any questions at this point? All right, I don't hear anything, so let's keep moving. Well, I guess I just already showed you how to push to GitHub. And then if all that worked, then great, congratulations. You have your local Git and GitHub connected. You're good to be using them from this point on. Okay, so there are two components that we're going to be using for GitHub this semester. One of them is you creating what we just did, creating the exercise on GitHub, cloning that to your computer, setting up the folders. However, at that point, you don't have yet the files that I share with you for you to move into those subfolders of data and script. That has not happened yet, right? Up until this point, the way that you've been doing it is you would go on GitHub, download the zip, and then do that manually, or at least downloading manually, and then moving the files also manually to your folders. What I want to show you today is how can you download our 2025 DSA repo through Git and using Git and GitHub to get the new files rather than manually downloading. So that's what we're going to do next. If you remember, we're going to do here a fork. So let me take one step back here. What you just did on your side was to clone. So you clone your own repo from GitHub to your computer. And the reason why you cloned is because you created on GitHub. So you have the rights of that repository. So you only had to clone. Now, on this next step here, if you remember, we talked about fork and clone. And we do a fork and clone when you do not own the repo, which is the case next. You did not own 2025 DSA. I own that. And because I'm not inviting you to be a collaborator on the repo, so you do not have direct access to, especially to push to the repo. So you're going to have to fork first and then clone. What the fork does, and you're going to see this as we do this next part of the step, is a fork basically, imagine an actual fork, taking the repo from someone else's GitHub profile, making a copy of that repo on your profile, and then you clone this copy that is on your profile. So you're not directly connected to the main source. You are first making a copy on your GitHub profile and then cloning from there. So that's what we're going to be doing next with 2025 DSA. All right, so here the first thing that you would have to do is to copy that Git URL, right? So I'm giving you here the address. If you're following the HTML slides, this is a link. I mean, it's just the link to the GitHub page for the 2025 DSA repo that I have. I'm just going to open this on a new tab. And then basically you would copy that URL, right? So remember that you're not copying this browser URL. You actually, I'm just left you the link here so it's easier for you to access, but you would basically come under code and then HTTPS and copy this. This is what I need you to copy. In this case specifically here, even though I'm telling you, asking you to copy, I'm already going to give you this link in the next step. So it's not as trivial, not as important, but that's how you would do with any other repo that you are forking. right? So first we need to get that Git URL from that repo. And then now we're gonna basically do the fork and clone directly on our studio. And again, everything we're doing here related to Git and GitHub, there are many different ways you can do this, right? You could do this completely independently of R. You could do this all in the terminal. Maybe you could use another IDE like GitHub desktop is an IDE you can use. There are others out there. There are many ways of doing this, right? I'm showing you one of them that I think perhaps is the simplest and easiest on your side. So if you come on our studio, it could be any R studio. It can even just be the 04 RCBD. It does not have to be the 04 RCBD. It can be any R studio environment that you open. If you just come here and we're gonna come on the console, decrease this width. We're gonna come on the console. Remember that the console is our code, right? This is where we do our code. If you're using the terminal, for example, to do git stage, git commit, git push, that is not in the console. That would be on the terminal tab if you have one on your RStudio. So console is R, so only our code here. We're gonna be using a package called use this. I think you have already installed this package if you follow the tutorial from last class. And so you would not have to reinstall it again. We're just going to use it. If you did not install, somehow you got through the exercise without installing, use this. You already know how to install a package, right? Install .packages and then use this in quotation marks if you have not installed. All right, so again, open any RStudio window. Doesn't matter if it is 04 CBD or not. On the console, so again, on the R side, on the console here, we're gonna copy the code below. If you are following my presentation on the browser, you can just click on this clipboard button and that's gonna copy the code for you, and then you can just come and paste in R. In case you are not following the presentation on your side, let me share a link to this slide so you can do that. Okay, so if you come here on this slide, basically want you to copy this code here and paste that into your R console. Now, what is going on here on this code? If you remember, this syntax here is package name : This is just to say, I want to use the function create from GitHub from the package use this. And then we're given here first the URL, the Git URL for the repo that we want to fork and clone, right? So this is that you would have copied on the previous step. And then we need to change here the dest dir, which is the destination directory on your side. So what I want you to do here is, let me move this a little bit. So still within the quotation marks, so make sure it is in quotation marks. If you just delete all this path to where you want the local repo and you just leave the tilde and /, this would probably, and you hit tab, this would be the root of your computer. It may be different for Windows PC, I'm not sure. If that is not if you're working on Windows and this is not doing what I'm showing on my side, let me know. We need to figure out a solution. But if you just leave the tilde and the / and you have your cursor blinking after that / and you hit tab, this is basically the root of your computer. And then what I want to ask you is for you to navigate to the folder of our course, right? So in my side, that would be desktop, or go on Google Drive. So as you know, this is a path. So as you select, you hit tab again, it shows you the next level, right? So that's what I'm doing here. UGA, I hit tab, teaching, and so on. I'm just going to navigate here to the folder of the course on my computer. Again, this is different for each one of us. So make sure you follow what's right on your side with the goal of the last thing here being the folder name on your computer where you have the course material. All right, so after you've done that, and then we have this last argument saying fork equals true, right? This is just to make sure that we're not cloning only, we're forking and cloning to make sure we have access to this. So I'm not gonna hit return on my side because I own this GitHub repo, so it would not let me fork and clone something I already own. On your side, if you click return, if you send this code to the console for it to be interpreted, it should show you some messages saying cloning, forking, cloning, and so on, and it should go through without giving you any errors. So go ahead and hit return and let me know if you have issues. Yes, Fabir.
Yeah, so when I delete the path and click on the tab, it's I saw the drop down menu of different folders on my computer, but part of them there's no desktop, and my class folder is on the desktop. So I don't know.
Okay, so let me just go back here. So Swabir is saying if you have the tilde and the forward slash and you hit tab, you don't see desktop.
Yeah, I don't see desktop as a folder. I saw desktop as a settings, and then I click on it, and then nothing is popping up. It's not. I don't see the desktop folder. So I don't know if somebody is experiencing something similar.
Yeah, I have the same problem.
Me too.
Me too.
Me too.
Yeah, I have it too.
Okay.
All right.
My problem is saying that my directory does not exist.
Okay, so something we tried last year that it worked. And just so I also have an understanding of everyone that was having issues, are you all Windows users or was there a Mac user having the issue as well?
Windows.
Dr.
Windows?
Bestos, so I also had this issue, but I tried 2 dots and then again slash, and then it shows the desktop folder.
Okay, awesome. Well, first, thanks, Wabir, for bringing this up. As we all saw, you were not the only one having this issue. And I was just asking to understand if it was a Windows and Mac problem or if it was more of a, or a different scenario, I guess. Perhaps it is related to Windows. So what we did last year, so Amandeep was mentioning that, so you had the tilde forward slash and then you did a dot forward slash, Amandeep? Yeah.
Yes, yeah.
Okay, so if you were having issues finding that path, try this. So having tilde and then 2 dots and then hit tab. And tell me if that works for you.
Oh, it didn't work.
It didn't?
No.
No, I think it just selects the desktop as a folder, like your final folder to deposit there.
Okay, so something we did last year that I remember was a solution as well. If you remember, you can use relative path. So this way is we're specifying the absolute path, right? Which is not reproducible. We don't do that whenever we can, we use relative paths. In this case, we were given the absolute path because it was just the first time you're doing this. You're not going to be doing this again. But if you just delete all that, just leave the quotation marks. You can hit tab there and see where you are, right? So that's going to show you where you are in your computer. So right now, because I was inside of the 04RCBD project, it is showing me the contents of that project on my side. And I know on my computer, 04RCBD is inside my project folder. So I could do a dot forward slash, hit tab again, and I think this would be the place that I want it to be, right? This is where we want to have the 2025 DSA. So maybe you can also try to navigate from where you are and going on the opposite direction rather than starting from the root and going forward. So maybe try that, so try to if you just hit tab here, it's going to show you where you are. and then you can kind of have an idea where you are in your computer. If you need to go up a level, so go back, // and then once you get to the folder of the course, that's where you want to be. I believe last year we had to actually do like another forward, // to get outside of the course folder and then click again on the course folder to kind of go back into it. So this is what I think last year worked for people that were having problems.
Yeah, it is working.
Okay, what about others that were having issues?
Yeah, it worked.
All right.
So are we putting it in the main folder or maybe in a subfolder?
So we want it to be inside of your main folder of the course, right? So you do not want to go inside 01 intro or 04 CBD. You want to be at the level of the course folder, the main course folder. So this is what you would see. Okay, so Zach is saying, I'm having an unexpected equal in the code that is registering as an error. I think it's signaling to the equal after -. So Zach, if you're having issues with an equal sign, it could be a few things. So one of them, make sure that you have your opening and closing quotation marks after -. Make sure you have a comma after that quotation mark. And then make sure you close the parentheses there. Okay, Pratiksha is also having the similar issue. So let's do this. I think we have maybe a couple people that are having issues. We will help you. I do want us to come back to this. Maybe you can reach out to Amrinder. He can connect with you individually by Zoom and see what's going on and help you figure that out. We're not gonna have, so my goal was to all of you to be able to do this so you can see through and see what will happen. But if you're not having issues, it may be a specific thing that's happening on your side that we may need to be in one-on-one to address that issue. You may have to share your screen. So just so I have an idea here, so Zach and Pratiksha were having issues. Is someone else still having issues?
Dr. Bastos, like maybe we can try if we put the full path of the directory. Like the folder which they want to save, if they go there, right click on that and copy path. And then that they paste on the R. Maybe if you give the full path of the directory, that can solve this problem.
Okay, so you're saying, Amrinder, like if you would go
So the folder which they want to save, whichever they want, especially in Windows.
So this is the folder that we want to save, at least on my side.
If you right click on this, there will be a copy a path in Windows option.
Okay, so let's try that. Let's try copy path and then pasting that path on the desk there as well, making sure that you leave the quotation marks there. So this is how that will look like on my side.
Yeah, maybe this could help out. If nothing, then I will solve the problem after the class.
Okay, so
Okay.
Zach and Pratiksha did that. If you try that, and let's see if that works.
Especially for the Windows user, like we have to also correct the slash. It is a backslash, we have to make the forward slash.
Thanks, Ashwin. So that's another thing. If you're using Windows, another difference is you may need to do a backward slash rather than forward slash, as I'm doing on the Mac.
Sorry, like you have to use the forward slash, not the backward one. But when you copy it, it will give you in the backward slash.
Oh, gotcha. Okay, sorry. So, all right, let me rephrase that then. So when you copy in Windows, it may give you the backward slash, but you have to change that to a forward slash. Yeah, so it's some differences between operating systems that always fun to troubleshoot. All right, so Zach and Pratiksha, if you're still having issues, we can connect with Aminder after class. Okay, so Pratiksha is still having issues. We're not gonna have to rely on this for today's class, but next Tuesday we will. And so if you're still having issues today, don't worry, we're gonna have time to make sure we got everyone on the same page before next Tuesday. All right, so for those of you that were successfully able to fork and clone, I want to show you a couple things. So if you go on your GitHub and you go on your repositories, now you should see one of the repositories being 2025 DSA as a fork. So I'm not showing on my side because I did not fork that because I own that repo, so I don't have to fork it. But on your side, you should now see that fork as part of your repositories. What that means, again, imagine you came to my GitHub profile, took a fork and stab my repo, I guess, and then place that back on your profile, and then you clone that version, the version on your profile, not on mine. So you have a clone of that. Now, every time I make changes to the original repo, which is on my profile, those changes will trickle down to all the forks that people may have done. So whenever I share files with you, you're going to be able to get those files through Git and GitHub very easily and not have to download manually. So a good example now, if you wanna test it. So if you now back to your computer, if you go on the class folder where I hope is where you did the fork and clone. So you should be seeing like 2025 DSA or something like that, but the version you cloned just now, right? Not the one you were manually downloading. If you open that folder, you do have, on my side, I don't, but on your side, you probably have an RStudio project icon, a .rproj. Double click on that .rproj. It's going to launch that RStudio project for the 2025 DSA. Every time I tell you, hey, I uploaded new files to GitHub, make sure you pull those files. All you have to do is go on your local 2025 DSA, launch that RStudio project, and then just click on the git pull, which is the down arrow. So you do a git pull, and that is going to pull any new files that I may have pushed to GitHub. Once you have pulled those files, you can go back to that folder, that 2025 DSA on your computer. And then if I tell you, hey, I just pushed a code, like a partial script in a data set, and I ask you to create a 04 RCBD, I want you to already be thinking, because I'm not going to be spelling this out every single time. I want you to be thinking, okay, I have to go on 2025 DSA, pull these changes, and then go on the class code, copy that script, go back to my 04 RCBD, paste that on the code folder, and the same thing for the data, right? So again, remember the 2025 DSA, I'm just using that to share files with you. I always want you to retrieve those files now through Git and GitHub, and then just copy them and pasting on your actual working project folder, which is going to be something like 04 RCBD, 05 split plot, or things like that, right? So just recapping it here. From Tuesday on, every time we start a new exercise, I'll ask you, hey, create a GitHub workflow for an exercise called 05 split plots. You're going to start on GitHub, create that, make a clone of that to your computer, create the subfolders ars code, code data and outputs. Then on the same email that I asked you to create that exercise, I'll probably say, I also uploaded or pushed to GitHub a code and a script to go along with that. So on another RStudio project, which is the one for 2025 GSA, you open that, you do a git pull by clicking on the down arrow, get all the files to your local computer, and then copy those files and paste on the 05 or 06 or 07 exercise folders. Okay, this is the workflow we're going to be doing in class. I think as you do that the first time, it's going to be a little bit more clear. But at this point, at least, any questions?
Dr. Bastos, so it means next time we don't have to repeat the use this dot dot colon colon create from GitHub. We don't need it anymore, right?
Yeah, so the fork and clone, which is that code that you all were doing now, you just do that once, right? Once it is forked and cloned, now that version that you have is connected to your fork, which is connected to my original one. So anytime that I upload a new file, all you have to do is just open that RStudio project inside 2025 DSA, which I don't have, but you do. And once that opens up, you're just going to click on the pull button, which is this one here. That's all.
Thank you. I have one more question.
Mhm.
So this use this as a package. Normally we use like library to import the package. So is this like another option we can use even for like, when we are working on other analysis? Let's say it's DeepLab, we can just do DPLR colon colon without using the library and importing.
That's a great question, Comfort. So the way that it works is if you do use the library function to call that package name, all functions under that package will be available to you, right? So you do not have to explicitly call the package name colon colon function name. If you do not call library, those functions are not available by default, right? So let's say on this, I have not loaded any package here, right? So let's say I wanted to use the filter function from dplyr. If I just start typing filter, I see that I get two options actually, but they're not coming from the dplyr package. They're coming from stats and base, which are two packages that ship with R, and all their functions are always available. If I want the function filter from dplyr, I can either do a library dplyr and then call for filter. And now I see there's a filter from dplyr available to me. Or if I had not loaded dplyr, I could explicitly call the package name dplyr colon colon, and then I have access to its functions. So you can do either way. If you know you're going to be using a lot of functions from the same package, I would recommend you to load the package, and then you don't have to be explicitly calling package name every time you use a function from that package. But it is an option.
Thank you.
Yeah, thanks for the question. Okay. So I think I10 is also having some issues. We can address those during office hours. I just want to make sure we get to start our next lecture today, which is going to start with the actual analysis that we'll be doing this semester. All right. Before we shift there, and besides just troubleshooting the fork and cloning step, anyone has any questions about what we've just done?
Dr. Bastos, is there any way like can we change the name of the repository on GitHub, or is it permanent?
Yeah, so you can change, Selvin, if you come to the repo. Let's see, I'm going to open the 04 RCBD 25 that I have. So it has where are the settings? Yeah, so it has a settings button. If I have this open larger, I think it would pop up there. So it has a settings button here that you can click, and you can change the name right there. He has a lot of options for different things, including like if you want to invite. So let's say if you created a private repo and you want to invite somebody to have access to it, to be able to see it, there is a collaborators tab that you invite people. Of course, they have to have an account with GitHub for that to work, but this is where you would do that. I mean, there are many things you can do here. Even if you want to, let's say, delete a repository for some reason, you can do that through here. So yeah, that's where you would change the name, but there are many, many options of things you can change the settings of on GitHub.
All right, thank you.
All right, thanks. Okay, so ideally, just to wrap this up, the setup that you should have at this point, if everything worked, was you should have a 04, or sorry, let me go back. You should have a 04 RCBD at the main folder of the course, where if you go in there, you have your RStudio project icon, the rproj, you have code data output and a README. As of now, you don't have anything in your code or data. I will share with you files on Monday, perhaps, or maybe earlier, and say, hey, I just pushed some files to GitHub. Go get those files and then copy and paste them inside 04 RCBD code and data. So that's coming. And then whenever I say that, you will come on your 2025 DSA that you forked and cloned, open that RStudio project, and then just click on that pull button to get the new files. And then the files will pop up on your computer, and then you just copy and paste into 04 RCBD. All right. Okay, so I'm gonna wrap this part up. And you know what? I think this is probably a good time for us to take a 5-minute break. If you need to stretch, get water, go to the restroom, whatever you wish. This is a good time for that. Once we're back, then we're going to be talking about experimental design and treatment designs as well. It's going to be a very key lecture for us to get started with that topic, and then we'll get into the exercise on Tuesday. So let me set up a timer here for 5 minutes. And we'll be back in 5.
Hi, Dr. Bastos.
Yes, Shakir.
Did you already upload the class code for the RCBD exercise? Because I did a pull and I don't see it on my folder.
Not
So,
yet.
okay, got
Yeah,
it. Thank you.
do that later this week. And also, one way to check, so let's say if I do upload and then you do a pull and you don't see the files, maybe something happened in the process when you were setting up that you're not actually connected. It's unlikely if you were able to do the fork and clone, but if in case that happens, you can always check by going straight to GitHub, right? So if you go on GitHub 2025 DSA and there are files there and you do a git pull and you don't have them on your computer, then it's a communication issue between Git and GitHub. But that should not happen always. But just, I guess to answer your question, another way of you checking that without asking me was you could go straight to GitHub to that repo and see if the files were there. Because if they are there, then you should be able to pull them.
Got it. Thank you.
Dr. Bastos.
I think you're muted.
So when I did that thing that Bastos for the hitting tab, so for me it was like I have to go manually, like first I have to choose desktop, then I have to hit tab again, then I have to choose the next folder until I reach the desired folder. So it was like 4 times I have to hit tab and select manually. It wasn't taking me directly to that folder.
You mean like on that function that we were specifying the path?
Yes, sir.
Yeah, that's normally how it would be, right? So if you have the / and then you hit tab with your cursor after the /, it would show you a list of what is seen at that level, right? And then you click on the folder and then it moves to the next level, hit tab again, select again, right? So that's how I did as well. That's how it should be, I guess.
Yes. In the last class, it was working fine. Like I just have to hit tab and it was showing the direct, like the folder which I was looking for. But today it was like manually going one by one.
Yeah, I think on previous classes, we were always really close, I guess, right? So we were, maybe the file was under code, you wanted to go one level up and then go into data. So it was a shorter path, I guess. Maybe that's why. But this time we kind of had to navigate from the beginning, or maybe from backwards, but yeah, maybe.
Okay. Okay, thank you.
Thanks, Isman.
Hello, Professor.
Hi, Charishma.
Hello, Professor. Is it possible for you to show me again after using that code how to pull the request?
So to do a git pull,
Yeah.
yeah, so the git pull is when I upload a new file and then I tell you all to download it, right? So you're going to be doing git pull. So that would happen. Let me see if I have a folder. Yeah, this. So whenever that happens, if you were able to do the fork and clone of 2025 DSA, you would go inside of that 2025 DSA. On your side, you're probably seeing a .rproj icon here. I don't have it because I own this repo, but you should probably be seeing that. You can double click on that rproj, so it launches this 2025 DSA project for you. And then once it launches it, let me just open any RStudio window to show you. For you to do a git pull, you just click on this button here. On this like it looks like a download button, which is, I guess, git pull, you're basically downloading from GitHub, right? So once you click there, any files that are on GitHub, but that you don't have yet on the 2025 DSA repo are gonna then be downloaded on your local computer. And then at that point, you can go back to the actual folder and then just copy and paste the code from here to the exercise folder, right? So in this case, you would copy, let's say, a class from class code. I'm going to share a code for the RCBD exercise. You copy from here, you go back, and then you go into that exercise 04 RCBD and paste it inside of the code folder of that project.
Okay. Thank you, Professor. I got it.
Yeah, absolutely. All right, so 5 minutes went by quickly. We're going to resume our class. We're going to 11:30 today. So we have still a little bit of time to cover the next material. All right, so this presentation that we were talking about, we wrapped that up. I would suggest that you keep this presentation in mind, maybe not for the 04 CBD, since you've done that already as part of this lecture. But as we do future exercises, we're gonna have probably, I don't know, 13 different projects in this course until the end. So we're gonna be going through this workflow a lot. If you need a refresher, a reminder of how to do those steps, you can always go back to this presentation here, which is under the January 21st class. This is our GitHub workflow, is the one that you would be looking for if you need that refresher. Okay, so if you go back to the class website, we're going to be talking about some key concepts in experimentation. If you remember, in this class, we're basically learning 3 different things intertwined. So we're learning about data science concepts like reproducibility, Git and GitHub. We're going to be using those tools while we learn about some of the most common and popular experimental designs in agriculture. And then we're going to get into machine learning and learn some algorithms on that side. So we talked about, intro to R, data wrangling, some reproducibility concepts, getting GitHub, and now we're going to get into experimentation concepts. They're going to be key for you to understand. If you, and most likely you have already seen this in previous stats courses, but if not, then this is a good lecture to be familiar with. All right, I'm going to launch this lecture from my side. This is on the January 23rd link. I'll make this a full screen. All right. So the goals that I have for us on this lecture here are to explore some very key concepts in experimentation. So we're going to first talk about what is an experimentation planning workflow, what are the components of that, how we think about when we're setting up an experiment, at least some things that we should be thinking when we're setting up an experiment. We're going to talk about hypothesis setting. So this is how do you come up with a hypothesis that is testable and what makes it a good hypothesis. Then we're going to talk about study design, which is basically a combination of your treatment design and your experimental design. Treatment design and experimental design are two different things on a study design, and we're going to understand the differences what does each one of them address in your study, and why they're both important. Then we're going to get into this conversation about what is an experimental unit or an observational unit. This is key because this sets up a lot of important concepts in experimentation. Like, for example, are you doing subsampling or not? The answer to that sometimes can be tricky, but most of the time, if you can understand what is your experimental unit and what is your observational unit, then you should be able to understand if you are doing subsampling or not. And that has key consequences on your analysis because it plays on the degrees of freedom you have. And we should know what we're doing. We should analyze our data properly according to the design we're using. And so this is a very key concept as well. Then we're going to talk about two of the most common designs in AC. CRD, which stands for completely randomized design, and RCBD, which stands for randomized complete block design. There are many designs out there. These are two of the most common, and we're going to have an exercise on RCBD. All right, so starting off here with experimentation planning workflow. So every study probably follows a similar workflow that is going to involve, a curiosity about a question. Maybe this started with you, especially if you're doing your PhD, you may bring your own questions to a project that's already ongoing that you're working with. Most of the time, this starts with your professor, right? Maybe they had a question that they want to answer. They probably wrote a proposal that got funded, that then they're paying you through that the funding from that proposal. So most of the time, students would come into a project kind of skipping this step, right? This step of asking a question is probably already done by your advisor, and you're just getting to do the actual work for that, to answer that question. But ideally, at some point in your career, in your graduate career, you would go through all these steps, which is first being curious about a specific question, creating hypotheses that are related to this question that you came up with, setting your objectives that are connected to that hypothesis. Then you're going to create a treatment design that is going to address those objectives. We're going to talk more in depth about this. So for now, let's just leave it at that. You're going to define what is your experimental unit, determine the level of homogeneity of your experimental unit. And based on that, you're going to create an experimental design that addresses experimental material homogeneity or a lack of it. And I'm giving you some hints of what does your treatment design addresses, what your experimental design addresses. But all that can kind of be summarized into this. So your treatment design here in the middle, sharing space with experimental design. Those are the two main components of your study design. And this is how those different pieces are coming or are related to treatment design and experimental design. So if we start here on the half left, where we're talking about treatment design. So again, it starts off with curiosity. You go to the literature, you do a literature review, you find gaps, you look for a way to, you look for a question that you think is interesting to answer. There is a gap in the literature. You set up your hypothesis, and then based on those hypotheses, you create objectives. Your treatment design then is completely connected to that. So setting objectives and answering those objectives are what treatment designs are supposed to do. On the other hand, on the other side of this workflow, we have experimental design. So experimental design is not what we use to answer your objectives. Experimental design is what we use to accommodate lack of homogeneity in experimental material. And that comes down to understanding what is your experimental unit, and also what is the level of the homogeneity or lack of homogeneity of the material you have at hand. We're going to get into more details about both of those things, but I wanted you to see this picture to kind of understand treatment design is connected to your objectives, experimental design is connected to your experimental material, and if you have lack of homogeneity, how you handle that. All right, so the next step here would be for us, or one of the first steps here would be for us to set some hypotheses. And I do have some guidelines here for us to think through. So first thing is that a hypothesis is, so you did your literature review, you identified gaps, you have some understanding of whatever it is you're studying, right? It's not like you're doing something completely unknown to anyone else. You have some understanding of that. So your hypothesis is basically you writing down what is your belief of what you think would happen before you conduct the experiment or before you collect the data, right? This is your belief coming in. What do you think is going to happen based on what you know already about this area without having run your study yet? And with that, a good hypothesis must be testable and has to be proved either right or wrong, but not both. So what I mean by that is when you write a hypothesis, you have to be bold. You have to say, yield is going to be affected by nitrogen fertilizer rates, will be affected or is affected. You have to be bold in that. Even if you're wrong, even if you do the study, collect the data, and you're wrong, that's fine. Right? People do say my hypothesis I was not able to, the data that was not, the evidence I collected was not in favor of my hypothesis. That happens a lot of times. You see that on paper. So it's okay if you write a hypothesis that was tested wrong at the end, but you do have to come in with a testable hypothesis that you can read that and say, I collect data, and when I come back to this hypothesis, I should be able to say yes or no. It worked, it did not work. Yeah, I guess that's what I just mentioned. And again, it's okay, right? If you write a hypothesis that is your current belief based on the literature, you have a strong hypothesis, and then you do a study, collect your data, and your data says, you know what, you hypothesized that this impacted that, but the data really does not show that. That's completely fine. It's okay if your hypothesis was not proved right. All right, so I want us to think about a scenario here. For those of you working with crops of any sort, I think you will be able to relate more easily. If you're not working with crops directly, maybe you can think about, a garden plant if you grow a garden, or a house plant if you grow a house plant. I think that would put you in the mindset of what we're asking here. And I would also try to, whenever I can, and I think there is space, I will try to provide some examples outside of crops. But in this case here, let's say that we hypothesize that increasing nitrogen and potassium fertilizer rates will increase corn grain yield. So in field studies, or I guess it doesn't have to be field study, but in this case here, our case study is a field study. You would imagine that crops would respond to fertilizer, right? So if you apply more fertilizer, crops are going to give more yield. In this case here, we're talking about corn grain yield, but it could be, a vegetable yield. It could be really any plant that is giving an output that you're interested. The better conditions you provide to that plant, the more it will produce until a biological limit. In this case here, the input that we're testing is fertilizer rates, right? So we all are probably familiar that plants need fertilizer, and if they don't have the right levels of fertilizer, they may not produce as well. So this is our hypothesis here, is that increasing nitrogen and potassium fertilizer rates will increase corn grain yields. So I want to open this question here and ask, do you think this is testable? And why do you think it is or it's not?
Yeah, I do think it is testable
All right, Shakir, why do you think that?
because we can design an experiment. We can have different treatments of nitrogen and potassium,
Okay.
and within the treatment blocks, we can, we have the yield, we can count the yield and compare with the treatments that has lower nitrogen and potassium rate versus the ones that has higher.
Okay.
And then we can interpret the data and come to a conclusion whether our hypothesis was right or not.
Okay. I like that. Now, let me show you another example. So, okay, so I agree with Shakir. I also think that the previous hypothesis was testable, and he explained why. What about this one here? If someone else can help me with this one. So I just changed the word slightly here, but now we're saying we hypothesize that increasing nitrogen and potassium fertilizer rates may increase corn grain yield. Is this one testable and why?
I think it's also testable.
Okay, so Comfort thinks is also testable. Why do you think that, Comfort?
It says may because it's not certain. So the results of the experiments will tell us whether it's increasing or maybe decreasing it.
Okay, well, thanks for sharing your thoughts. Anyone disagrees with Comfort's thoughts?
I I still agree with comfort, but the may sounds kind of like we're throwing into the wild. Like probably will work, probably won't. So in this case, it's not like could be an hypothesis. It's more like, okay, we're doing this, we will see what will happen.
Yes, perfect. Thanks, Ruben. Yeah, so this is so Comfort. Maybe what you're thinking is if you I mean we normally don't know what's going to happen, right? That's if we knew, we would not be doing a study most likely, right? If there's something that was for sure known. So that uncertainty always exists. However, in a hypothesis, we have to be bold, even if you're wrong in the end, right? So this hypothesis here is not really testable in the sense because if the data says that increases, then the hypothesis is true. But if the data says it does not affect or maybe decreases yield, then the hypothesis is also true because I had that may there that weakens the hypothesis, right? So the hypothesis should be written in a way that the data is going to say that it is either right or wrong. It cannot be right regardless of what happens, right? So it is not a very good testable hypothesis because it just leaves room open and is not really like you as a researcher or us as researchers, we're not compromising. We're not saying this is what I believe will happen, even if in the end you're proved wrong. But you have to come in with a good idea of what would happen, right? So this here is not the best hypothesis. I've been in review panels for grants and review papers, and especially in review panels, whenever we have a hypothesis that is weak like this, that always raises concerns from the reviewers. So we want to be bold and we want, even if we're wrong at the end, but you want to come in with a good understanding of what you think will happen and putting your coins on that. Yes, Comfort.
Yeah, what if you change it to something like we hypothesize that increasing N and K fertilizer rates will influence corn grain yield?
Yes, that's what
Is
we
that
had.
testable?
Yes, sorry. Yeah, so that's what we had in the first example, right? So I'm just gonna go back to the previous slide. We had that will. We were saying this is what will happen.
No, like instead of increase, you say like affects or influence. You're not specifying whether it's increasing or decreasing.
I see what you're saying. Yes, so I guess a couple of things, right? So one of them is we do not want to use words that weaken our hypothesis like may, right? However, what you're saying is we could say will, but we could say impact or affect. So you're not given a direction, right? You're not saying if that's going to be higher or lower. You're just saying something will happen. It is also a testable hypothesis, right? It is perhaps not the strongest hypothesis because you're not giving a direction, but at least you're saying that something will happen. It was not going to be the same as not applying it, right? So we still have a hypothesis that's going to be either less than or more than, but it will not be the same as. Yeah, awesome. Great questions. All right, so last and third example here. What about now? Is it a good testable hypothesis? Is it not? And why? Maybe someone that hasn't helped yet.
It should say will increase.
Okay, so Micah, what do you think is weakening this hypothesis?
Can is still a more hypothetical word to use.
Can, is that what you said?
Yeah.
Yeah, I totally agree. Yes, thanks, Micah. Absolutely, right? So we were saying can is like it can be, but it can also not be, and it would still be the hypothesis is in this safe zone that whatever happens, the hypothesis is right, right? Because it can, but it cannot as well. So yes, can is weakening this hypothesis as well. We want to be bold about what we believe coming in, right? So we would change can by will or something that shows your belief more true. More truly. All right, thanks everyone. That helped. Okay, so you define your hypothesis. So in our case, we're hypothesizing that increasing nitrogen potassium fertilizer will increase corn grain yield. Now your objectives come after that. They should stem directly from your hypothesis, right? So again, bringing back our hypothesis that increasing N and K will increase corn grain yield, our objectives then should be connected to our hypothesis, right? So our objective is to assess the effect of different nitrogen and potassium fertilizer rates on corn grain yield. It's just a slightly different wording, but they have to be connected, right? And especially so when we're writing papers, I mean, there are many things that make a good paper a good paper, but one of them is to have a very clear hypothesis coming in because then the reader can really see, okay, we're testing this, so here's the data, here's the evidence, were we able to prove this right or wrong, right? And especially as students, if you're competing on posters and oral presentations, normally this combo of having hypotheses and objectives gives you points, right? Or if you don't have them, you lose points because you have to have that this is what sets you on the path of experimentation, of how you determine your treatments and so on. So having these very clear for everything you do is going to be helpful for you and also for your audience whenever you're sharing your results with them. Okay, so then we're coming back to this idea. So you had a question, you create a hypothesis, you create your objectives. So now let's talk about the design of the study to address these objectives. We started with that, talking about the study design, which I'm calling here study design, the combination of both the treatment and experimental design. When you combine both of them, you have your study design. This concept of treatment and experimental design is something that is taught in every stats class that's related to experimentation. However, I still see a lot of confusion when we apply that. Like some students that I've worked with in the past were confused about these concepts. They thought that design was design, that they did not understand the difference between treatment and experimental design or what was their purpose. And so I want to bring this concept here for us to explore and make sure you understand what they are and when we use each one of them, what's the purpose, and so on. All right, so treatment design is going to be the part of your study that is directly related to what treatment factors and treatment levels you need to answer your objective and how they are related to one another. So for example, if you think of nitrogen potassium fertilizer rates, well, I think we're going to have that conversation in the next slide, so I'm going to pin that for now. But basically, your treatment design is the part of your study that will help you answer the question that you establish on your objectives. That's what treatment design is there for. Its role. And then our goal is, once we know our question, our objective, now we need to think of what different treatments we need to have in a study so we can answer that question, right? So we need to have the factors and the respective levels that will properly address the research question. So let's think together. If we stop for a second here and think about the example that we are talking about. So if I want to, well, let me take one quick step back and explain for those that may not be as familiar with this type of research. So whenever we are increasing the level of an input, in this case, fertilizer, and expecting a change on an output, in this case, corn grain yield. If that system is a biological system like this is, there will be a biological limit. So let's say, assuming that corn plants are limited by nitrogen especially, which that's true in many cases. If you apply no nitrogen, you get a certain amount of yield. If you start increasing the amount of fertilizer, that yield starts to increase until a point, and then it kind of plateaus out after that, because there is a biological limit in place, right? So normally there are optimal levels. You cannot say like keep increasing forever and you will increase yield forever. That does not happen, right? This is a biological limit. It has a limit to how much the plants will respond to any input, in this case, fertilizer. So what we are interested in doing is finding what is the optimum level of fertilizer to optimize yield. I don't want to apply less than that because I'm losing yield. I don't want to apply more than that because I'm increasing costs without increasing yield, right? So we want to find that optimal level. So if we want to find the optimal level of any input, in this case, fertilizer, I really need to treat the crop with different levels of the input so I can estimate at which level the yield response is maximized, right? Now, since we have two inputs in this example, nitrogen and potassium, we need to do that. We need to select multiple levels of those fertilizer rates for both of those fertilizer types or nutrients, nitrogen and potassium. Also, it is possible that nitrogen and potassium interact. Maybe if I apply X amount of nitrogen and no potassium, I'm going to get less yield than applying the same amount of nitrogen with potassium. So they may be interacting as well, and we may be interested in that effect too. So not just the effect of nitrogen alone and potassium alone, but also how they interact with each other, right? So we have two treatment factors, which are nitrogen and potassium. And now, I'm going to ask for some of you to help me to just, come up with some levels of those fertilizer treatments. So let's see here. If we think about nitrogen first, if you were to test this hypothesis, and given that we know there is a limit to how much plants can respond to any input, in this case, fertilizer, what are some levels that you would recommend for nitrogen, for example? Maybe this would make more sense if you have worked with fertilizers before, so so we're talking about like kilograms per hectare of nitrogen. I know not everybody in the class works with that with that type of application. So if you work with that type of application or with fertilizer in general, how many rates would you have, and maybe what are some of those rates? Ashbin, I think you're not muted, but I cannot hear you. I'm not sure if it's on my side or yours. Cannot hear you. Let's see. Well, while Ashbin tries to troubleshoot on his side, anyone else that has worked with crops can help me think about it.
I haven't directly worked with nitrogen, but I've seen my colleagues. So usually then 135 kilogram per hectare and 202 kilogram per hectare. That's 3 rates
Okay.
of nitrogen.
Can you repeat the rates, Comfort? I missed that.
0 kilogram per hectare, which is the control, then 135 kilogram per hectare, then 202 kilogram per hectare of nitrogen.
Perfect. Thanks, Comfort. Yeah, so that would be very common. Like you want to have a 0, which is your check, right? To really be able to say increasing nitrogen, increase yield. But so we have to have something that does not receive nitrogen so you can understand that response a little bit better. And then having at least 2 more rates, maybe between 4 to 5 is better. But yeah, so we could have a 0 and then an intermediate rate and then a high rate, like what Comfort was saying. Thanks, Comfort. So I agree with I have in my example, and of course, these numbers here are just an example, right? They're not a hard rule. We're just testing different levels. The numbers Comfort said were very plausible and made a lot of sense. I'm proposing here we do a 0, 100, and 200 kilos of nitrogen per hectare. Was somebody saying something? I see Swabir has a question. Go ahead.
Yeah, so I also work with corn. I don't know if these fertilizer rates are just for examples, or maybe we are targeting a specific yield goals.
A specific what?
Are we targeting a specific yield goal, or we are just taking like any nitrogen rates just for the class?
So we're not targeting a yield goal, specifically in this case, but that's a great point. So we're not gonna go into that side of the conversation just because I think it adds more complexity to those that don't work with row crops. What you're completely right, Swabir. If you were if this study was actually being your study, we would have to think about yield goals and how much nitrogen has to be applied to match that yield goal, and then maybe have a rate that was lower than yield goal, a rate that was the yield goal rate, and then a rate that was higher than that, right? So we'll probably do a few changes here, but so you're completely right. For the sake of the class here, we're going to stick with these and not get into that conversation, but that's definitely what should be done in that case. Awesome. Someone else had any questions? All right, I'm going to keep moving here then. So the next thing would be potassium fertilizer. So potassium is needed in less quantities than nitrogen, at least for corn. So we also have 3 rates, and then we have a 0, which is the check, and then 2 other rates as well. This, I just want to take one step here and say, if this is not fully connecting to you, you can think of anything on your area of expertise that you increase the levels of something and expect something to happen with an organism, right? So for example, if you are in food science, this could be, instead of nitrogen and potassium rates, this could be temperature or maybe pH. If you're working with pathogens or insects, this could be also temperature, humidity, growing degree days, anything that is continuous that increases, and you would expect that increase on certain levels of an input to have an effect on a response variable. Most of the time, the response variable in agronomy, in crop and soils, is yield, but it could be anything else, right? It could be maybe quality, maybe cotton fiber quality. It could be the presence or absence of an insect or disease, or maybe how many bacteria have left after you increase pH beyond a certain point. So anything that you are increasing the levels on the x-axis and expecting a response on a organism on the y-axis is probably a good way of thinking of this, if this example does not click directly to what you do. All right, so we chose here 3 levels of nitrogen and 3 levels of potassium. And I guess what you've been hearing me say, and if you're not familiar with this, this is a very important, simple yet important concept for you to understand. So nitrogen fertilizer and potassium fertilizer are treatment factors. They're treatment factors. 0, 100, and 200 for nitrogen, and 0, 30, and 60 for potassium are treatment levels. So factor is like the name of that. the thing, nitrogen fertilizer. This is the factor, and the levels are the levels you selected within that factor to answer your hypothesis. So this nomenclature between what is a treatment factor, what is a treatment level is also important to be familiar with. So here's just a note for that, right? So treatment factors are potassium and nitrogen fertilizer, and then treatment levels are what amounts of that fertilizer you selected to be tested in your study. Okay, so our question here, our original hypothesis and objective was that nitrogen and potassium fertilizer affects corn yield. We talked about that if you want to test that, you have to have multiple levels of each one of those factors. So we selected 3 nitrogen rates and 3 potassium rates. It could have been more. I don't think less would have been helpful, but maybe having 4 or 5 or even more than that would be good. We're just playing with 3 and 3 to keep things simple. And we do believe that there may be an interaction between those rates. So again, what does that mean is maybe if I apply 100 kilos of nitrogen and no potassium, I'm going to get less yield than if I apply the same 100 kilos of nitrogen with some application of potassium. So when they work together better than any of them alone, this would be an interaction, right? So if we believe that's true, which most of the time we have that understanding, then that leaves us with 3 levels of nitrogen fertilizer times 3 levels of potassium fertilizer equaling 9 total treatment combinations, right? So maybe you thought, okay, I just need 6 treatments because it's each individual rate of phosphorus and potassium, or of nitrogen and potassium. But if you want to be able to assess the interacting effects of both, then you need to have all those levels combined. So all 3 levels of nitrogen times all 3 levels of potassium, leaving us with 9 total treatment combinations. So in other words, I need to have all those treatment combinations to be able to answer my hypothesis of the effect of nitrogen and potassium on corn grain yield. This specific design here would be called a crossed two-way factorial. It is crossed, well, maybe let me begin by the factorial. It is a two-way factorial because we have 2 treatment factors, and it is crossed because all of their levels are appearing with each other, right? So I have all levels of nitrogen appearing with all levels of potassium with a total of 9 treatment combinations. So you can also refer to this as being a crossed 2 nitrogen rate by, 3 nitrogen rate by 3 potassium rate factorial treatment design. And again, this is just the treatment design. If you remember, treatment design is what we determine to answer our objectives and hypothesis. That is the goal of treatment design. In our case here, our treatments are crossed, meaning that every level of nitrogen appears with every level of potassium for a total of 9 combinations. This is called cross because, again, everything happens with everything else equally on the same level of importance. There are also some studies where you would have a nested structure. So instead of crossed, you have a nested structure, which is in contrast with crossed. So a nested structure, for example, would happen when the levels of one treatment factor are allocated within the levels of the other treatment factor. This happens, I know that I just said some words that if you're not familiar with nested designs, the words I said probably made little sense to you, and that's completely fine at this point. But one good example here would be a split plot. So if you've ever heard of a split plot, or maybe if you even conducted a split plot, and we're going to see that in class, so you would get exposure to that as well. You basically have a level of one treatment factor, and then you split the levels of the other treatment factor inside this. So a good example here would be, again, I'm giving examples of agronomy, so I apologize if that does not click with you, but I hope you can understand the concept behind it and still understand an application on your area of expertise. But for example, if you're working with irrigation treatments. If you have never worked with irrigation, you don't know what I'm talking about. In large agricultural fields, a lot of production systems are irrigated, meaning they apply water to compensate for lack of rain, for example. In those cases, the equipment that applies water to the crop is very big. And it's not something that you can make a small plot and have, here I irrigate, here I don't. If those plots are too small, you cannot accommodate that because the equipment is too big that is applying that water treatment, that irrigation treatment. So you have to have larger pieces of land that receive an irrigation treatment. So let's say you have, I don't know, a large plot that receives no irrigation, and then another plot of the same size to the side of it that receives some irrigation. So irrigation is limited by being applied in a large area, but fertilizer is not. We have equipment that can apply fertilizer in a small area. So in that case, you may have your irrigation treatments. So all this area receives no irrigation, and then inside of it, you have all of your nitrogen and potassium treatments. So nitrogen and potassium are nested within irrigation instead of crossed. This is, again, we're going to get to an example of this, an applied example that I hope it will help you understand it. But just to say that treatments can be crossed, or treatment factors can be crossed or nested. And a split plot would be a great example of a nested design. And normally because of experimental material limitations. In this case, you can only apply different irrigation levels to very large parts of the field, but you could apply nitrogen and potassium to smaller parts. Okay, so some final thoughts around treatment design. So notice that now we had our question. We want to test nitrogen and potassium. Those are our factors. We chose 3 levels under each factor. And because we're interested in the interaction of both nitrogen and potassium, we crossed all those levels for a total of 9 treatments that we need for this study. Right? So notice that all of our treatment design has done was to address our objectives. That is what we need to apply and collect data from that to be able to answer our objective. That's all treatment design has done for us and will do for us in this example. So what is the use of experimental design then? I think this is probably a great stopping point for us. We just have 3 more minutes. I don't want to overwhelm you with brand new information that we're not going to have a lot of time to talk about. So for today, let's stop here at treatment design. Next class, we're going to finish this lecture and we're going to start an example with coding to analyze a randomized complete block design study. I do want to tell you that last semester, I did have a full exercise on completely randomized design. I decided to skip that on this class because that's the simplest design. You probably have had experience with it already. If you have not had experience with it yet, and you do want to go through that lecture and go through the coding of that, let me know. Depending on how many people want it, I can set something up. I can share videos and scripts and all that. We're just not going to cover that in class. So if enough people find that interesting, I may have like an extra credit assignment on that. But anyways, if you are interested in running a completely randomized design study in R, let me know and I can just have an understanding of how many people are interested. But in class, we're going to skip straight to the RCBD, so we have more time for machine learning at the end. Okay, before I open for questions, I just want to go on GitHub and open for attendance. Oh, Arminder has already opened it. Thanks, Arminder. Make sure you claim your attendance before you leave, especially on these online classes that is harder for me to know if you were there or not. Make sure you claim your attendance if you were here. And while you do that, if you don't have any questions, oh, you know something else? Hold on, just a second. Right. So claim your attendance. Before dismissed, I just want to let you know so UGA, Department of Crop and Soils, we have a integrative precision agriculture club, which is, I think most people there are probably graduate students. You may be already part of it. If you're not, and if you're interested in precision ag, this is a new club that is bringing people from industry, trainings, gatherings, things like that around people that are related to precision ag or have an interest in that. I'm bringing all this up right now because today there is a speaker, Chris Rhodes. He is the Director of Industry Partnerships and Project-Based Learning. It's going to happen live here in Athens with food and beverages. It will be also streamed by Zoom to other campuses. There are people in different campuses that are part of this club, so you don't have to be in Athens to be a participant. And I just went to grab the flyer. I can, yeah, this is not gonna work. I'm in there. Can you send an email later for everyone with the flyer? Yeah, I'll ask Arminder to share this. I think Arminder
Sorry, I was muted. I can share that.
Okay, perfect. So it's today at 5:30. There's going to be food and beverages and a lot of great conversations. If you're in Athens, it's going to be live here. And I believe in Tifton, perhaps in Griffin. Well, no, I think in Tifton there's going to be free food as well. But
Yes, it will be in NASPAL seminar. If you want to go there, there will be free food.
Okay, perfect.
And
Just sorry for the
we have
Griffin
different social media if you guys want to connect on that. Like we have on Facebook, Instagram, Twitter, and LinkedIn for the IP Club. If you guys want to connect with that one, you guys are more than welcome. Thank you.
Awesome. Amrinder, so since you're a TA for the class and you can send emails to the class list,
I will send you.
you send the flyer and then more information. If you all interested, if you just want to check out, I think it's great opportunities and there's many things that this is a brand new club. It started in that last semester, but there's a great opportunity for growth and involvement. And if you're interested in precision. All right. If you claimed your attendance and if you don't have questions, you are good to go. I'm going to stick around just for a few more minutes in case somebody has questions. And also, if you had issues with anything we did today in class, as far as getting GitHub, get in touch with our mentor who's going to help you out to get that solved.
Yeah. So I will be available for next 1 hour here. So if anyone have any questions, just email and we can have a Zoom call right now.
All right. Thanks, everyone.
Thank you, Professor.
Thanks, Reshma.